Thanks so much, Raj. It's really cool to be speaking for you again and for your meetup. Well, g'day from Australia. My name's Ashley Davis. Today I'm talking about rapid full stack development. Throughout my career, I've worked with many different languages, frameworks, APIs, and so on. Our industry changes quickly, so there's always something new. But one thing that's really remained constant for me is my ongoing quest to be a better developer. I've spent a lot of time thinking about this topic of rapid development, and it turned into a much bigger topic than I expected. And it's been actually quite difficult to trim this down to something that's presentable, just the essentials really. Figuring out how I can be more productive, how I can get more done, and also most importantly, how I can get the right stuff done. So I'm always looking for ways to refine my development process. And today I want to share with you some of the things that I've learned and that have helped me. Now, there's way more than I can say that can possibly fit in this talk. So to that end, I'd like to announce that next year, I'm going to be writing a new book on this topic. I'm just going to share my screen now so you can see the webpage that I've set up for it. Okay, so this is the webpage that I have up for the new book. I'm going to be working on this next year. It's rapidfullstackdevelopment.com. If you like what I've got to say in this talk and you want to hear more, please subscribe. You can show me that you want this book, and then also you'll get updates. As I write it, as I read each chapter, I can send you updates. So I'm just going to switch over to my slides as well. So you'll notice on each slide here, I've got my contact details. So and also the website if you want to visit that. These are on every slide. So you can write this down or look me up whenever you want. Please feel free to reach out, contact me by email or by Twitter. Now, I'll just say a little bit about myself before we get into it. I've been a software developer for a long time. I'm currently VP of engineering for a new startup called Optio. We're building some really exciting products that build on the Algorand blockchain. So if you're into blockchain stuff, stay tuned because we'll be announcing our products in the new year. And I'm sure you'll think they're as cool as I do. I'm also the developer of DataForge Notebook, which is a cross-platform tool for doing exploratory coding and data analysis in JavaScript and Typescript. I've written some books. So I've written a book called Data Wrangling with JavaScript. The most recent book I wrote is Bootstrapping Microservices. And next year, I want to write rapid full stack development. So that's news. Not too many people know that yet. Before we get into some of the bits and pieces about why and how you do this, I just want to get you thinking. So I'm going to ask you this question: what is the fastest way to write code? Now, I don't expect you to give me an answer. In fact, there is no right answer to this question, so I'll just say that up front. But soon we're going to come back to this, and I'll give you my answer to this question. What's the fastest way to write code? So at the beginning, who is this talk for? It's really for developers at any level. I hope at any level of experience that you're going to be able to get some value from what I have to say. Particularly, this applies to you as the individual developer. Although, if you're managing a team, I'm sure you'll get some value out of this as well. But this is really aimed at what you can do as an individual developer, to make sure that you can move fast as a developer. Mostly I do JavaScript and TypeScript these days. And so naturally, I'm going to talk about why JavaScript is good for fast development. And I'm going to be giving a live demo. So we're going to start with some theory, but then I'll do a live demo and I'll show you some practical techniques for moving quickly as a developer. Now, this talk, it isn't just aimed at JavaScript and TypeScript developers. So if that's not you, please don't turn away because you will get something out of this as well. There's a lot of crossover to every language, every runtime, every framework that is out there. The things that make you fast as a developer, cross multiple languages. So what does it all mean to be a rapid developer? Well, there's no one size fits all solution to this. I believe I have techniques that work, techniques that have proven themselves to me. You'll have to try them out for yourself and see what works for you. Above all, it's a state of mind. It's an attitude. You can adopt this state of mind that can help you become a better developer, progress your career, and hopefully also, have a more satisfying career as a developer as well. The main theme of this talk is improving the rate at which we produce working and reliable code. Note the words working, working, not working in reliable code's good as well, but working in valuable code. So, valuable is the key thing here, because it's not just about how much code we write or how fast we write it. Our code, it needs to work, it needs to be reliable, and it also needs to be useful. Above all, I want you to think about what I have to say and think about what it means for you. I want you to take this away and experiment with it and see if you can make it work for you, or make it work better for you. And feel free to come back and tell me as well. Like if you play around with these techniques and you can improve on them, I'd love to know that. So you've got my contact details on every slide. Please feel free to reach out to me. So how do we go about becoming rapid developers? Well, first we have to identify and reduce the things that slow us down. We have to employ attitude, techniques, and tools that enable, empower, and scale us. We're aiming to deliver a flow of value for our organization. But it's important that the process should be sustainable. We need a process that includes downtime so that we can have periods of rest and be able to maintain a fast pace indefinitely. A primary concern is to reduce the amount of time we are wasting. And typically for us developers, that's the time we spend accidentally doing tasks, or like going down the rabbit hole, as they say, spending way more time on tasks than we should. When those tasks, maybe haven't been prioritized at the most valuable level. So where does JavaScript fit in, and what's it got to do with it? Here's a picture of what full stack looks like with JavaScript. And if you know anything about JavaScript, or if you've heard me talking about it before, you'll know that you can do almost anything with JavaScript. It's the one language that can run all the way across the stack. And that means we can move freely around in our stack without incurring a cognitive penalty that would occur like if we had to switch languages. So we don't have to reload like a new programming language into our brain when we change between front end, back end, and mobile. That's great news for small teams, startups, and solo developers, and maybe good news also for enterprises, for the ones that want to compete with fast-moving startups. If you add to this the kind of conventions that we have in JavaScript, they can also reduce the cognitive load and help us be able to change between projects very quickly and very easily. I'm going to give you an idea of what that looks like soon in the live demo. So JavaScript is full stack, and that means as a JavaScript developer, like no part of the stack is off limits to you. You can easily go anywhere. Now, of course, that kind of depends on the culture of your workplace as well. But as a small team or a solo developer, or as creating a startup like what I've done, you can bootstrap everything yourself, and you can go anywhere. Nowhere's off limits. JavaScript is also a dynamic language, and that can help us build a fast workflow. Being able to easily run JavaScript makes live reload possible. I'm going to show you what that looks like in the live demo. Being dynamic also makes JavaScript great for rapid prototyping. It's also great for working with data. It also makes automated testing much easier. For example, it's so much easier to create mock objects in JavaScript than many other languages. Then we can layer TypeScript on top of JavaScript and get the benefits of compile time error checking and static typing. We can choose to trade off some short-term coding speed for more safety and less errors in the long run. The really amazing thing about TypeScript is that it can also be very flexible. It's like we can mix and match the best of dynamic and static worlds to create the mix that's best for us and that helps us work, as fast as we can. JavaScript has a huge and rapidly evolving ecosystem. Now, for some who are newcomers to the JavaScript ecosystem, this could be frightening or overwhelming. But just know this, as JavaScript developers, we have so many tools at our disposal. And fortunately, we can tell the good ones pretty easily. They're the ones that tend to rise to the top, the ones that have that are popular, have a following, have the best resources and learning materials, and the ones that are also easiest to use. So as JavaScript developers or as TypeScript developers, we have some of the best tools of any programming language. And our tools are always improving as well. And that's due to the huge community engagement that we have. In particular, I want to call out some of our automated testing tools like Mocha, Jest, and Cypress. These are some of the ones that I use in my process, and they make testing in JavaScript an absolute joy. Excuse me. So what can we do to help us become rapid developers? Well, first, I want to circle back to this question. What's the fastest way to write code? Well, I can tell you that it doesn't have anything to do with typing faster. That said, like fast and accurate typing, it doesn't hurt. It's good to be able to type as quickly and accurately as you can, but that's not the answer. The truth is that the fastest way to write code is simply not to write the code in the first place. I'm just going to take a moment and let that sink in. The fastest code you can write is the code that you preemptively eliminate because you realize you don't even need it. And the fact is that so much of the code we write ends up becoming redundant. It's wasted. The problem is that code is expensive. If you were able to predict the code that was redundant or what experiments were going to fail, we could simply not write that code in the first place and then save on everything that it's going to cost you down the line. So keep that in mind. Code has a cost. And code costs not just in development time, but also in debugging and maintenance. These are what we have to do longer term as developers. So code creates baggage that we must bear going into the future. Another way to look at this is to say we should choose carefully the code that we decide to write. Be careful where you invest your time. You should choose to write code with the most obvious value and steer clear or be wary of coding, something that has like a value that's not well known or not well understood yet. I ask this question because I hope it makes you think and because I also think it highlights something important about prioritization. Finding where you can deliver the most value, finding the best place to invest your time. Those are important parts of becoming a faster developer. I've just got a few people in the waiting room. I'm just going to let them in. Okay, hopefully that looks good. The starting point of writing good and valuable code is your brain. It sounds obvious, I know. But your brain is your most valuable tool, so please make sure you're using it. And as a coder, it's tempting to get into this habit of code first, think later. But I challenge you to find ways to break this cycle and put the thinking before the coding. Development is a continual balancing act, and it requires not only thinking about how to code something, you also have to understand how that code fits into your team, your company, your product. And if you aren't already prioritizing your work, you should be. One of the most important ways that we can prioritize our work is based on its value to the organization. But this also has to be balanced against the cost of actually building it or delivering it in the first place. And the problem is that we often don't know how much something costs to build until we're building it. So during coding, we must be mindful of how long it's going to take to finish something. And if the cost of that blows out, we have to reassess if that outweighs its value to the organization. Now, you can't always answer these questions by yourself, but the thinking about it starts with you. And then you've got to go to your manager or your colleagues for help, if you need it, for help getting a better understanding of the bigger picture. You probably had this experience yourself where you're coding all day or, for some long stretch of time. And then when you come to testing your code, nothing works. You spend subsequent hours or maybe even days, figuring out how to get your code into a working condition. Now, simply put, that's a terrible way to work. But because nothing big in software development gets created like that. The key that unlocks successful software development is iterations. You take something big and complex and difficult, and you break it down into smaller and smaller chunks. Each iteration, it should be simple, very simple. If each iteration is not simple, that means you have not broken it down enough. Now, I should mention here that I'm talking about personal work iterations and not the larger iterations that are called sprints that we typically use in agile teams. I'm going to show you soon how these personal iterations kind of fit. Well, you'll see when I'm coming up. I've got a diagram on a slide soon. The best workflow is a cycle that includes looking at feedback, reviewing our work, and then adjusting our course to always be heading in the best possible direction. Having thinking embedded in our process is what enables us to be dynamic and frequently reevaluate what we're doing and change directions when we need to, when new options become available, or become more obvious. This is especially useful because, sometimes the clarity only comes when we are partway through, building a feature or some sort of task that we're working on. So now, how can we structure our iterations? Well, I like to use a system called the Pomodoro Technique. A Pomodoro is a timed interval or iteration of work. Because each iteration is timed, we can use this for time boxing. That's a really great technique for productivity. If you haven't heard of it, you should look up time boxing. Including breaks is also really important because that helps this process be sustainable. And we can't be rapid developers, if we're constantly exhausted, if we're working ourselves to the point of exhaustion, that it's going to affect our work badly. In case you're wondering what a Pomodoro is the Italian word for tomato. And it's called the Pomodoro Technique because its inventor, Francesco Cirillo, used a kitchen timer that looks like this to schedule his work intervals. You can see that the timer goes up to 25 minutes, and that's why the default time for a Pomodoro is set to 25 minutes, and that's followed by a 5-minute break. So the total iteration time rounds out nicely at 30 minutes. If you want to structure your iterations using Pomodoros, you don't need a timer like this. Obviously, if you've got this timer buzzing, if you're in an office, probably most of us are working from home these days, so it doesn't matter. But if you're working in an office, having a timer going off, it's not going to impress your colleagues. But if you search online for Pomodoro, you're going to find heaps of apps that you can run on your computer to do this, or just use the timer on your phone and run it on silent. You'll feel the vibration. This diagram shows how Pomodoros can be linked together to create a series of iterations. Now, the important thing you get from this process is natural gaps in which to insert thinking about what you are doing. Frequent reassessment of your priorities and estimation of your current tasks should be part of your process. Through repetition of this process, we can build a good work habit. And you don't have to stick to the 25-minute rule. If 25 minutes seems like it's going to be too short, choose a larger interval time, 1 hour, 2 hours. Experiment with this and see what works for you. Okay, this here is my most fundamental rule of development. You need to keep your code working. Before we look at how to keep our code working, I just want to quickly define what it means for code to be working. And I think I have a fairly simple definition of this. First of all, our code has to compile. It has to be free of syntax errors. If you're using plain old JavaScript, this won't be an issue for you because you don't compile it. But many people use a build pipeline with JavaScript these days that will do kind of linting or checking on it. Or if you're using a compiled language like Typescript, your code has to pass through the build process without error before you can run it. So that's the first thing. Next, our code needs to run without significant errors. There might be runtime errors in our code that we might not want to fix. We know about them, but we don't want to fix them, and we can work around them. That's okay. We can deal with that. That's okay. But any errors which clearly break the functionality of the code, they need to be fixed directly. So it's not working unless it really satisfies what the code needs to be doing. Also, there might be errors in the code that we don't know about yet, but obviously we can't do anything about those until we find them, and then we can fix them. But finally, our code needs to pass whatever tests that we choose to throw at it. So we need to have test cases that pass. Here is the simple cycle at the heart of of a coding workflow. I do some coding, I test the code, I check the result. I do some coding, I test the code, I check the result, and so on. We are coding in small increments, testing and assessing the result each time. The amount of time you spend coding, it doesn't really matter. Sometimes it will be shorter, sometimes longer. The important thing is to minimize the amount of time you code before you test, because the less code you write in one go, it's easier to test. So I'm like talking about, don't be afraid to just write a line of code and then test it. Like that's how short it can be, or it could be minutes. If you start taking tens of minutes or perhaps hours of coding before testing, that's when you're going to start writing broken code. That's going to be very, very hard to debug, very, very difficult to prove, where we'll figure out where problems are. So minimize that time you spend coding before testing. And it's also important to have this tight feedback loop. So we're constantly coding, testing, seeing the results of our tests, and being able to assess whether how far the code is from working, and being able to correct it to get it into a working state. Now, the quicker you can see the results of your code changes, the faster your development pace can be. Coding and testing are supposed to be done together in a tight loop like this. And testing, it's just not something you can leave until later. If it's worth coding, it also has to be worth testing. It's only when you unfold the loop of repeated, small, well-tested changes that you can really see the power of this process. Imagine this sequence stretched out over some hours or even some days. We start with a simple beginning, possibly just a line of code, and then we work through a series of small code changes. Each code change, because it's small and simple, it's easy to test. So at no point during this sequence is testing difficult or overwhelming. We have baked testing into the heart of our coding cycle. Through this series of small, simple changes, we accumulate a large body of working code. The key point here is that the starting point is simple and that each subsequent step is simple. But through these steps, we build up to a complex application. The coding cycle is usually shorter than the Pomodoro cycle, and that means we can fit multiple coding loops, multiple iterations of coding, multiple increments of coding into each personal work iteration. Now, it depends on what you're coding and how difficult it is. But like I said, it can be as much as a single line of code that you then test, or a few lines of code. Maybe you've been coding for a few minutes and you test, but typically it is that short. Code for a couple of minutes, test, code for a couple of minutes, test. Don't leave it too long. You will end up with very badly broken code the longer you leave it before you test. Here's the most important thing. This simple idea, it's so powerful, and it's so easy to kind of bring this mindset into your coding process. At the start of a coding increment, our code should be in a working state. When we add code or we change code, we have to get it working again. So the aim is to keep the change minimal and then return as quickly as possible to the working state. So the output, as it were, of a coding increment is our code changed, but returned to this working state. And anything we can do to minimize the time between working states, that's going to dramatically speed up our development process. So I just want to repeat this mantra again. If there's anything you remember from the talk, please remember this. Keep your code working. I've been talking a lot about testing, and you might naturally have assumed that I meant automated testing. The thing about automated testing is that it has a cost. Automated testing, it is a substantial investment. So here's the question you have to ask. Is the code worth the investment of automated testing? Now, you know, when we're considering this, we have to think not just about the cost of the code, but we have to think about the cost of the code plus the testing. So that makes a big difference. And we have to weigh that up against its value to the organization. The fact is that not all code needs to have automated testing. For some code, manual testing is perfectly okay, and automated testing is just going to be a waste of time. Knowing when to do automated testing and when not to, that's part of the balancing act of being a software developer. And it's not always an easy decision to make. I made this flow chart that can help you with the decision-making process of when you should do automated testing. But sorry, I'm not going to give you enough time really to go through this. But I will put this chart online later, so please check online and you will find it somewhere. Now, there are many projects where automated testing will pay for itself because it can remove many countless hours of manual testing from your development process. And that is going to do a lot to make you a faster developer. But I don't think it matters at all whether you're testing first or testing later, if you know what that means. You'll see on the next slide. But what matters is that you test your code. That's the main thing, right? You one way or another, you've always got to test your code. It's not optional. But what we can do is if we are in a position to be able to automate the tests, then all future testing, you know, is free basically. We can run those tests as many times as we want, and they're not going to cost us anything. What automated testing does is it captures our feedback loop and preserves it, so you can rerun it as many times as you like. Automated testing provides fast feedback. And of course, you have to write fast tests for that to be true. But that gives us the closest thing we can get to instant feedback. And this fast feedback, it's part of the power of automated testing. Now, so test-driven development, or TDD, like what I called test first as opposed to test later. TDD is not the only approach to automated testing. I learned TDD and I practiced it for a few years, and I still use it sometimes. But I realized that TDD, it isn't really necessary, although sometimes it's useful. And I do recommend that people learn TDD though, because it's a great starting point. It will make you a better developer, and it's a really well documented way to learn automated testing. In a moment, I'm going to try and show you in the live demo, I'm going to show you a way to do testing, automated testing that's not TDD, just to give you an idea of what that looks like. Now, because we talked about automated testing, I can now talk about refactoring. So the aim of refactoring is to strive towards clean and elegant code. Having clean code is important because, you know, that's easier for us to maintain and update. Having bad code, badly structured code, you know, where any change you make causes bugs, that kind of thing, that's going to slow us down. So we want clean and elegant code. It doesn't have to be perfect. That's why on the slide I've called it cleanish code, because perfection, it's unattainable anyway. And if you're trying to get there, you're going to waste a lot of time trying to achieve it. And you know, everyone's idea of perfection is different. So, you know, it's a bad idea to try and aim for perfection. You know, aim for what works and what's valuable, but not perfection. Now, I like to think of refactoring as part of our job as a developer, and it's not something that we can, you know, put off for a rainy day or, you know, put on the backlog for later. It's something we should be doing a little bit of every day. But the main thing for me to say here is that refactoring without automated testing, or you know, or at least without sufficient manual testing, it's very dangerous, and you can break your code very badly. So please take care with your refactoring and try to make sure you have good automated tests to back you up, and, you know, make sure you can always return your code to a working state. Developers spend a lot of time chasing bugs. So anything that we can do to minimize bugs or make them quicker to fix, it's going to be, you know, it's going to help speed you up. There are plenty of techniques to preemptively reduce the occurrence of defects. I've written a blog post for this. Look on my blog, codecapers.com.au, and you'll see that. I document a whole bunch of different ways there to stop bugs early in the development process, stopping bugs from going to production. That can save you a lot of time down the road. And there are many ways that I could help you improve at debugging, but we only really have time for one practical technique. And you know, sometimes to solve the most difficult problems, we need to free ourselves of the baggage of our normal code base. If you can take code that has a problem and then reproduce it in a smaller test bed, then that problem is going to be much easier to find and solve. And once you fix the problem, you can transplant that code back into your production code base. For this reason, like I always like to have a test bed handy for whatever kind of language or framework runtime that I'm working with. I'm going to show you a couple of examples of that in the live demo in a moment. So the other thing I want to mention is that like any craftsperson, and I like to think of myself as a craftsperson, you need to have a good tool set. And so, having good tools and knowing how to use them, it's really important to being an effective developer. And you should always be looking to identify and fill gaps that you have in your toolkit. And also be looking to, if you've got certain tools that perhaps slow you down, or you suspect makes you less effective than you could be, you need to be looking for replacements for those tools. And if you already feel like your toolkit is complete, that's cool as well. But I bet you can go deeper into it and continue to learn to a deeper level the tools you already know, learn how to use them more effectively, find out how your colleagues use them. And there's plenty of ways to figure out how to get more out of what you're already using. One of the most important tools in our toolkit is version control. For most of us these days, I think that's Git. And I wanted to mention version control just so that I could show you how it fits into the cycle of coding. There are many reasons why we can't do without version control, and I've written extensively about them on my blog as well. But the most important thing to say is that version control captures the tested output of your coding cycle. Now, I say you should do small changes to your code because small changes are easier to test, but I also think you should do small commits to version control. So you should commit code whenever you have accumulated enough tested changes to make a sensible commit. What makes a sensible commit? Well, that's a little bit more difficult to explain, but it's the smallest amount of code that is testable, that doesn't leave loose ends, and that helps us move towards whatever feature we are currently implementing. So you might be into implementing a particular feature. It might take you a few days, but that's going to be like, for me, that would be a few commits every day. It wouldn't be like 3 days and then one commit for the whole feature. No, make it smaller than that. And so you should be aiming to reduce the amount of time coding between testing, but also aim to reduce the amount of time between commits. Now, why is that important? Why should we aim for small commits? There's a very good reason for it. If you ever get into a situation where you've made a mess of your working copy of code, you want to be able to back out of that situation without losing much work. And in a moment, I'm going to show you how to do that with Git. But backing yourself out of a messed up situation is much more difficult if you have accumulated a large amount of code changes that you don't want to give up. Now, instead, if you've been doing small commits, you can always back out of that situation by doing a Git reset, and you won't lose much work. So it's like, for anyone who's played Monopoly, it's like having a get out of jail free card, right? For when you stuff up your code. But you only get it if you always use small commits. So I'm going to do a live demo now, and I'm going to show you some of the tools you have in your toolbox that you can use to work quickly. Now they are, conventions that allow you to move between projects quickly. Live reload, so that you can change code and see it update almost instantly. Automated testing, so running unit tests and integration tests. Using a test bed as a simpler way of playing with code where you don't have all the baggage of a big production application. Doing a Git reset, and then a little bit about doing mobile dev using web technology. So there's a lot to cover. I'm not going to cover it in any great details. It's really just to give you a bit of a taste. Now, before we do this, I'll show you where you can get some of the code we're going to be playing with. I just have to adjust my screen a little bit so I can see this with the Zoom toolbar. This is the blog post I was telling you about before as well, stopping mistakes from getting to production. So if you look at my webpage on my blog, codecapers.com.au, there's a bunch of techniques here that will help you stop mistakes, bugs, getting to production, which is the cheapest place to deal with them before they become a problem, for customers. So check that out if you're interested in that. We're going to be looking at, for one thing, we're going to be looking at is DataForge. Just to show you, just to demonstrate a couple of techniques. DataForge here is my TypeScript library that you can use from JavaScript or TypeScript. It's a library for working with data and doing data wrangling in JavaScript, which is something I wrote my book about. This is a library that you can use in the browser, in Node.js, and in mobile dev. So, it compiles down to JavaScript that can be used basically anywhere in your stack. I'm also going to be showing you my TypeScript template, which is a small TypeScript application, which has nothing in it. It's like a template for a new application, but I always use this as my test bed. Whenever I need to try out a little bit of code, or take a bit of problematic code out of the bigger code base and try it, I use there. I've got a similar thing here. Also, so this is in my Git account. So go to Ashley Davis on GitHub, look up TypeScript template. This one here is a front-end version of that. So React Parcel TypeScript example. These might not be technologies that you're interested in, but what I want to impress on you is that you should have your own little testbed applications for whatever you're working with, whatever language you're working with, whatever runtime. Have a testbed to hand that you can call up to use whenever you need to. It's a really impressive thing. So bring up my terminal. Now, the first thing I like to do when I'm returning to a project, so I've got this, I've cloned this repo locally. I've got all the source code here. I've installed dependencies already, so I'm already set up. I've done a bunch of setup work already that you haven't seen. It's not easy. It's not difficult to set up. So you can easily do this. You can easily set up yourself if you follow the instructions in the README on GitHub. Now, whenever I'm returning to a project for a coding session, however long that's going to be, the first thing I like to do is run the tests. So there's a convention in Node and using NPM, the package manager, NPM test. No matter what project you're in, that will run the tests. And it doesn't matter what testing framework it is either. It could be like, personally, I use Mocha, Jest, or Cypress. There's a bunch of other ones you could choose from. But whatever they are, NPM test, if you've set up your project correctly, of course, you have to conform to these conventions for them to work. But whatever project I go to, whether it's this one or any of the other projects that I work on, I remember this one command, and that's all I have to remember. So conventions really help. I don't have to kind of read any notes or remember what framework I'm using or anything like that. So that's really nice. So I have got 765 passing tests here in this test suite. So it's a medium-sized library. It's not small. It's not huge. But you can see, I can run that again. You can see that these tests come up pretty quickly. So it's not, and this tests a good proportion of the code in this project. So I can make changes, I can run the tests, and I can see very quickly if I've broken anything or had any kind of bad side effects. And this is running on a laptop. This is running on a slow laptop. It runs even more instantly on my desktop. Obviously not quite instantly, but if you architect your tests carefully to run fast, then you can have a really fast testing pipeline. Now, one thing I like to do to make my life a little bit easier on a day-to-day basis is use aliases. So I could run npm test every time I wanted to test, but I actually have an alias set up for RT. So RT does the same thing. It runs my tests. And that's not a convention across Node or anything like that. That's just my personal convention. I have that set up for my own projects. So I follow the normal conventions, but I also have my slightly faster conventions layered on top of that, which really help. Now, one thing that's really useful is to run npm test watch. This isn't really like a big convention, in our ecosystem either. It's just like this particular name, test colon watch, is like my personal convention. A bunch of other people use it as well. I think it's a pretty popular name. But this is what I've got to run it with npm run. But this is what I run to run my tests in live reload mode. So I'll show you how that works. I'll use my alias as well. So I also have an alias for this, RTW, that allows me to quickly start up my tests in watch mode. And I try to follow that same convention on any project that I personally own. Let me open. I've got Visual Studio Code already open for this project, so let me bring that up. Now the code doesn't really matter. I just want you to notice what happens. Like, so you don't really have to read this code or understand it or anything like that. Don't worry about that. I'm just going to show you what happens when I break this code. So I'm just going to accidentally kind of make a typo or something there, and that automatically reruns the tests, as you can see, and I've got a broken test. So let me just zoom out a little bit. So don't worry too much about what this code means or what the test means. Just know that let's just pretend I kind of conjured up this broken test, but let's just pretend that I was, I didn't realize I'd broken it. But because the tests make it obvious, the tests make it obvious that you've broken something. So I can come back here and I can kind of say, oh, I don't really want that. In fact, I'll do the Git reset right now. So I'll cancel those tests. I'll look at my Git status, and you can see that I've got a couple of things modified here. Now, because I haven't accumulated any change, I'm doing small commits, and I'm committing every time I've got a sensible commit. So I haven't accumulated any kind of working changes here, and I can know pretty quickly, like if I'm in a good position just to revert what I've done. So we can pretend that I've broken it in some way that I can't comprehend, even though we know what I just did. Of course, we just got to imagine. But I've broken it in some way that I can't figure out how to fix. The simplest way to get out of this situation is do a git reset hard. Oh, sorry, if I spell it right. Now, if I do a git status now, I've got no modifications. So I should be, hopefully, fingers crossed, I'm back to a working state, but I'll run my tests again just to make sure. You can see here that where I typed that number 5, that's gone back to what it used to be. So let's pretend I was in a bad situation there. It would have been in real life. It's much more difficult, obviously, to figure out than that. But all I did to get out of that situation was just reverted my working copy to the previous version. So that's a simple way to get out of trouble and get your code back to a working state when you don't necessarily understand what you've done or it's too hard to fix. Now, I'd like to show you how to configure live reload and configure automated tests, but maybe that's a different talk, because I really just want to get across the importance of some of these techniques, and how you set them up doesn't really matter, and it's going to be different depending on if you're using a different language or a different runtime. It's going to be different anyway. So I won't worry too much about showing you how these things are set up, although if people want that, obviously I'm going to write a book about this next year, so I'm going to put everything in there, like about how to actually set this stuff up. But if people really want it sooner than that, let me know. I can organize to do a different talk on the topic. Now, I'm going to put my tests back in watch mode here, and I'm going to demonstrate a bit of testing. I'm going to test. I've got a standard deviation function here. It relies a lot on the variance function. But I'm going to let's pretend that I've just written that function, and I do have a test here for it. I've got a bunch of tests here for it, actually. It's not like there's just one test for that. There's a bunch of different tests for different types of inputs. Here it is here. So, but this is the realistic test for standard deviation that I got from a statistics textbook. Let's pretend that I haven't written that yet. Let's pretend that I haven't tested this function yet, and that I've just coded it, and that I'm not doing test-driven development. There is a way to do this. You're going to think it's cheating. If you hadn't thought of this before, you hadn't seen this before, you're going to think it's cheating. But at the end of the day, whether you're doing TDD, whether you're testing first or testing later, it doesn't matter. It doesn't matter to me. What matters to me is that I have good coverage from automated tests in my development process. And it doesn't matter whether it came from TDD or test later, or however you want to build your tests. So we could write a test for this. I'm just going to going to try and keep the code really simple so it doesn't take a lot of time. I'm going to copy the input that I've got in the test, but let's just pretend, you know, I got that from somewhere else. You know, maybe there was a problem in the code, and this particular input demonstrates the problem, and I'm going to write a test that's broken, and I'm going to fix it. Now, I'm going to create a new series from that input like that, and then I'm going to call the expect function, and I'm going to call the standard deviation function on the series. And what should it be equal to? That, I mean, that's the big question, right? You know, what are we testing? What is the result of this supposed to be equal to? Do we know? I mean, sure. I could look this up in the textbook like I did. You know, that's why I put this series of numbers there in the first place, is because I could put like a well-known answer to this problem in my test. But there's an easier way to do it. But for this to work, you have to assume that the code that I've written in this standard deviation function is correct. But I think we can make that call, right? If you're coding something and you test it carefully manually, then you can assume that it works. And if it doesn't work, I mean, you're going to find out later. You're going to find a bug later, and you're going to write tests that prove that you fix that bug, and so on. But let's just assume that I've carefully tested this. I've understood the code. I know that it works. But what I do is I start by just putting some bogus value in here. Like I've just put 0. Obviously, it's not going to be 0. Like, how's that going to work? But you'll notice here on the right that it tells me the answer. Like, this is the cheating part of it, right? I can copy that out. Now my tests are going to rerun that I've saved my code, and I've got a passing test. So I just magicked a test out of nowhere by running the code that I have, you know, that I've manually tested. So I'm confident that code works. I let the code itself tell me what the answer is, and then I bake that answer in. So this is a style of testing that's kind of like opposite to TDD. But at the end of the day, if you get the tests, you get the tests. You know, no one's going to even know if you did TDD. So it can work. Now, the next thing I want to show you is in my TypeScript template. So this is what I showed you on GitHub a moment ago. I've cloned it locally. I've installed the dependencies. I've done all the setup, so you don't have to sit here and watch me do that. I have got it open in Visual Studio Code here. But what I want to do, I just want to show you, like, so this project, this DataForge project, it's got hundreds of tests, like over 700 tests. I can't remember how much code's in here. Like, this one file has like thousands of lines of code in it, and it's just one of the files in the library, right? So it's a big project, and like there's a lot of baggage there. There's a lot of surrounding code that can kind of interfere with what you're doing. Now, what I like to do, you know, if you have some code that's causing a problem, or some code that you just want to experiment on, you just want to play with and see what makes the code tick. Like, say this code here in the standardize function. Say I want to kind of take this out and put it into my test bed. I copy that from the original big project, and then I go to my test bed project, which I've got here. And this is just the kind of the stub that I've got. So just stub code that I've got on my template. I can delete all that hopefully, and just put my code in there. Now I'll put that on the side so you can kind of see the result. Actually, what I'm going to do is I'm just going to start with that commented out, just so I can run this. So I can run this. I run this in my kind of dev mode, start:dev. So that's my personal convention for starting in development mode. That runs in live reload, so that every time I change the code, it's going to restart. You know, it's going to restart the code for this project. Now, I also have an alias for this, a shorter alias that I use personally. So just to make it faster, I run RSD for run start dev. You can see here that just translates to run start dev anyway. So it's the same thing. It's just less keyword to start it. Oh, I've got, I probably shouldn't have deleted that code that was in there, because I do have a test, I think, that's relying on that. So let me just bring that code back, because I just want to make sure that this test bed works before I even kind of put the other code. So this runs, and it just printed, it should just print a date. Oh, I didn't save it. Anyway, it's automatically restarting because of the live reload, but I just want to start this clean, because I don't want you to see any nasty errors there. But so just running RSD npm run start dev, my personal convention to start this. All this project does is just print out the date. But now I'll copy my code from my other project in. Obviously, it's going to be broken at the start, so this is going to automatically reload. So, and there's a whole bunch of failures there. But that's because I've just copied this over with no care, like about what I've done. But I can go through this now, and I can kind of take out, put some known numbers in here for things. Maybe these are special numbers that kind of make it break in a certain way. Don't think I need that. Let's just, this is where I need kind of some test data. So just get rid of that. I'm just putting some like kind of random numbers in here, really. Nothing, these numbers are nothing special. This is just a demonstration. And so I've almost to the point where I've got this code working. I'm just going to console log the result. Console log is like your best friend when you're coding in JavaScript or TypeScript, just to see what's going on in the code. You can put that anywhere. One of the things I love about JavaScript is you can even spelunk down into your dependencies and just put a console log anywhere you like to see what your dependencies or the tools that you're relying on are using. Now this has restarted and it's actually printed out a result. So that's an example of how to pull some code out of a larger application and into this tiny little project. There's nothing to it. There's no baggage. Obviously, the code didn't work straight away. I had to make some changes. You have to do that. You have to possibly pull in some other dependencies. It's not always as easy as that. But it's a really important technique for like, just stripping away all the slow build process and the baggage that you get with a normal product, and being able to freely play with code and experiment with it. And like you're like a sculptor playing with clay or something like that, just in this really kind of raw environment where it's just so much easier to deal with. Now, the last thing I want to do is I want to show you a little bit about building mobile applications with Webtech. So for that, I like to use Ionic. So you can find it at the Ionic framework. There's a great little getting started guide. I haven't done much to start this new application. There's like nothing in it except for what you get, when you generate the sort of the stub application from the Ionic CLI tool. So there's instructions here for installing it and creating your first application. You can choose whether you want to start it blank or with tabs or with the side menu. I've created a little application that I've got running here. It's the side menu version. So you'll see the side menu in a second. I've already run this because it takes a while to start up, and I don't want to have to, for you to have to watch that. But at the end of the day, it's just like an npm install to start this. So like any Node.js project, any project built on JavaScript, it follows these conventions, which mean that we can create this application and then we can just start it, and we don't have to know any kind of command line options or anything specific to Ionic to get this thing to run. It just works really quickly and really easily like that. Now, I've already got the code for this loaded in Visual Studio Code. Let me find that. And I have the web page open. So I have the web page for this project running. So you're probably thinking now, it's a mobile app. Like, why is it running in a web page? So here's the web page that shows you this. Here's the side menu. Well, the fact is this is all built on web technology. So we can run it in the browser, and that is fantastic for testing. I can't tell you how amazing that is for testing. So when we're making changes to this, and we're hopefully, if you already know JavaScript and HTML and stuff like that, the web technologies, then you can easily build this out really quickly, and you can run it. Obviously, you can build it to like a native application to run on iOS or Android and put in the Play Store or the App Store. So, but the fact that we can test it in a browser just means that we can be really, really fast in our development process. And we're looking at here as like a full screen web app. So there's not much to it. It just gives you like a bit of a stub, and you can put your own stuff in here. But this is like what it would look like as a web page. So it's not only a mobile application, you could also deploy this as a web application, which is pretty cool. But let's go into the dev tools. So I'm just hitting F12 to go into the dev tools. But you can click this button here to go down to the mobile form factor. So we're kind of looking at this like it is kind of like that mobile screen size. And you can see I can pop out the side menu, and you can see all the kind of the regular HTML and CSS stuff on the side here in the dev tools. I'm just going to put that off to one side, and I might just move the dev tools to the bottom so we can just see this thing updating. So I've got the code for it on the side here. You can have this set up to be React or Vue, or probably even just plain HTML or CSS. So you can kind of set this up however you want. Angular as well, I think, is supported. I like React, so I always build these using React. But you know, I can go in here and I can make changes. So I'm going to say hello world. I'm going to save my code. You look on the right, and the hello world just pops up. So that's how easy it is to kind of, and then you just basically like live editing your mobile application, right? And you can make whatever changes you want, and they show up really, really quickly. So that's about it for the live demo. We're almost done. I just want to leave you with this. I want you to make a commitment to spending 10 minutes a day thinking and improving yourself. Just set aside 10 minutes each morning. Ask yourself, how can I improve? What can I do today to be more effective than yesterday? Start to build a habit around this, and you will be on the road to being a better developer. And there's no end to it. There's always something we can be better at, but it's a journey. It's an ongoing journey we can take, and hopefully you can enjoy it as well. I love learning. I love learning how to be the best version of myself. So love it. Have that attitude, and you will go places. I've got so much more to say, and that's why I'm going to be writing a book about this next year. If you like this talk, please check out the website rapidfullstackdevelopment.com, and let me know if you want this book, because I want to write it for an audience, and I need to know if you want it. So please join the email list, and I will send you updates as I write it. Thanks so much for listening, and it's been an absolute pleasure to be able to talk to you. I'm just going to have a look at the chat and see if we've got any questions coming up. So we've got a few questions in the chat. Good IDE and relevant frameworks. So, I mean, hopefully I've told you already some of the things that I use. So myself, I'm coding every day in Visual Studio Code. I used to use Mocha all the time for testing. So, typically I'm working on Node.js or I'm doing front-end coding. So I'm a full stack developer working for my startup. And but I transitioned to Jest, but some of my old projects are still running on Mocha. So, I can't decide which one I like better, to be honest. They both have their strong points. Cypress is amazing for testing web pages, and there are some alternatives to Cypress as well that I would suggest you check out. But Cypress is pretty cool. So that's my general testing framework. I routinely develop on a Windows 10 machine, but I also have a Mac, and I also have a Linux machine. Depending on when I'm doing testing for mobile applications, I need a Mac to run that. If I'm testing software to run on the Mac, I use the Mac. I build cross-platform software that runs on Linux. So I use Linux to test it sometimes. And typically my servers, my backends, run on Linux as well. So and my orchestration framework of choice, if you've read my book, Bootstrapping Microservices, is Kubernetes. So I'm a huge fan of deploying software to Kubernetes. It's Kubernetes, even though people say it's complicated, it's much easier to use than you might imagine, because all the major cloud vendors use it. Personally, for a lot of side projects, I use DigitalOcean. And so it's so easy. Click a couple of buttons and you can spin up a Kubernetes cluster, and then you just have to know some YAML in order to be able to kind of boot a server or something running on Kubernetes. Someone's asked, is this meeting about MeanStack? And the answer is no. MeanStack is using Angular. So I definitely don't use Angular. I used to use MeanStack, but it was quite a few years ago. And when it came to work on or to change to Angular 2, I decided I didn't really like Angular 2 that much. And I learned a little bit of React and decided I liked React. So I have been on the React side of things since then. But Angular 2 is great as well. I've got a mate that works with Vue. He loves it. He swears by it. We're spoiled to choice as developers in this ecosystem, that we have so many good frameworks. And there's heaps of smaller frameworks as well. So don't think you have to be stuck, learning the most popular stack or whatever you think the most popular stack is. There's heaps, you know, like the mean stack, or what's the other one, the MERN stack. You know, that's just that's just a series of technologies. You know, you can literally build your own stack. Just pick the best technologies, or the technologies that you like the most, the technologies that fit your personality best. That's a funny way to look at it, but that's the way I see it. You know, if you choose something that sort of fits your personality, then you're going to do really well with that technology. So make up whatever stack you want. Give it your own acronym. You know, it doesn't have to be anyone particular. What development tools and environment you most use? Hopefully, I've covered that. What else we got? I think that's about it. Any other questions people want to ask in the chat here?
Is there anyone have any question?
Or feel free to unmute and talk to me directly.
I think actually no one has any more questions. Okay, so it was a good session. It is a good session, and I definitely believe the way you were given the talk with some background, then the hands-on coding, it's really helpful, and would love to have more sessions with you as you are writing that rapid full stack development book. So please, I will have a chat with you, and I will try to organize more sessions in the coming months.
Yeah, for sure. And like I said, I could dive deeper on how to actually build these live reload pipelines and automated testing pipelines as well. Yep. So if you want another talk on that, maybe that's something for, you know, next couple of months down the line.
Yeah, sure. So that's something definitely we would love to do. And we're also trying to organize, as I said in the earlier conversation, we'll have some, we'll have two conference, one virtual conference next year and one physical conference based on the COVID situation. We have a lot of interest from different groups, from Facebook, LinkedIn, and Meetup. So I think a lot of audience has great interest to learn about your new book, how they're going to do the rapid full stack development. A lot of developers, engineers, they're struggling. So it's a really interesting topic. So if you could cover more sessions in future, it would be really helpful. And at the same time, sure, for our audience, our guests, if they would like to attend any conference in future, please keep in touch with us. And if you'd like to buy any book from many publications, they're giving some discount for you. So Ashley already have 2 books, so feel free to buy those books. And if you need any other help, please reach to me or Ashley for any sort of future learning. I think that's all for today now. But let's see, is there any other question for anyone? I don't see anyone has any question. So Ashley, thanks for joining from Brisbane, Australia. It's a great pleasure to have you one more time. I would love to have you one more time in more time in future. So yeah, so I think that's a good session. Let's talk offline and let's keep in touch.
All right, thanks Raj, thanks everyone. Pleasure to speak, and I'll see you again in a couple of months hopefully.
Yeah, see you again. Thank you everyone. Bye-bye.
Bye-bye.